let's see. Okay, so yeah, I'm James. I work. Sorry. Damn it. I'm James from LIGO Caltech. I basically work in distributed computing for LIGO and the broader IGWN community. My role is something like facilitator, stroke grid admin, stroke operations, and general kind of thorn in the side path. So I'm going to give you a few slides talking about some tooling that I've put together to basically make my life easier and report problems to Path, Condor, and OSG and support users. So this is kind of the grid exerciser stuff from the agenda. Okay, so if you're not familiar with the branding, IGWN is the kind of modern terminology for the broader gravitational wave network community, the collaboration of collaborations. So, you know, LIGO, Virgo, Cagra, and of course, GEO. Within IGWN, we have a bunch of different astrophysics groups targeting different sources with lots of different methodologies. I'm not going to say anything at all about the science really here. For that, I'd encourage you to go to the keynote session on Thursday. But yeah, so basically with all these different sources and methods, what we end up with is this really diverse zoo of different software, job requirements, latency requirements even, and of course computational costs. There's a little graphic on the right there, kind of roughly explaining that. So yeah, to date, our resource consumption is still mostly based in local pools with local submissions to those pools. So I looked this morning for the last year, and I think it's still about 75% in local pools for various reasons. But we do have a goal to basically try and encourage particularly the higher latency and more computational expensive analyses, and especially GPU-based analyses, to use the kind of distributed IGWN pool, as we refer to it. So this graphic is basically a hopefully very quick schematic of what I mean by the IGWN pool. So typically our computing model, at least for the distributed setup, looks something like this. We have production access to the various production access points, typically at the LIGO lab managed clusters. We host our own central managers. Those of course talk to the local Condor pools with shared file systems and easy access to particularly to proprietary data and so on, and public HTML servers. But then the IGWN pool is essentially the set of distributed resources, so various dedicated IGWN affiliated sites, HPC centers, WLCG places in Europe, and of course, various friendly OS sites. And then of course, the other aspect is the middleware layer, kind of operated by OSG, so the dedicated IGWN front end and factories. So that's a lot to keep track of. There's a lot of things that can go wrong. So there's, basically the things to keep track of might involve things like the overall functionality, plumbing, access points, talking to central managers, basically our jobs running at sites which we think should be running our jobs. Case in point, I think maybe about a year and a half, maybe even 2 years ago now, I started systematically going through places where I thought jobs should be running, and found that there was a pretty vast number of places where they were not, and we had some evidence to think that they should be. So that might be, past job histories, looking at factory entries, things like that. So that's mostly resolved now, but there's still some flux with places going dark, particularly self-hosted CEs. So I'd definitely recommend the hosted CE solution if you're looking into it. Other things that we want to keep track of, more application-specific aspects of what's going on. So basically, our jobs succeeding, reasonably well across all sites in the pool. Are they able to access data at the expected places as advertised, which is often not the case. More recently, I've started constructing a shiny new list, my list of woe. So this is basically a process of documenting sites which I've just started noticing are really not well configured for what our users really want. So another example being that right now there are actually no multi-core slots at any LIGO managed sites. despite some of our most computationally demanding analyses and IGWN pool friendly analyses being enthusiastically using multi-core jobs. And then the other thing that is kind of on my plate to a large extent is trying to test and demonstrate new or new-ish features, particularly in Condor, that we might have directly requested. So yeah, there's a lot of challenges in keeping track of all those things as well. So one kind of major thing is, historically, maybe less so now that O4 has started, but historically, our computing usage, particularly on distributed resources, can be kind of intermittent and stochastic. It's, at least in the past, there'll be huge bursts with relatively rare detections. That's less of an issue now that we're getting so many. So that lack of constant pressure means that it's actually really easy particularly for site level outages, to basically go unnoticed. We're not paying enough attention. And it's even sometimes hard to distinguish larger scale problems from just the lack of demand. So things like maybe one of the factories, one of the OSG factories going offline, that can just look like a quiet time in the IGWN pool. We also face a slight issue that we have a relatively small, it is growing, but relatively small base of users who are brave enough to go for the distributed approach. I don't particularly want to rely on users to report problems. Power users tend to work around them and sometimes not even report them at all. And it just scares off novice users back to the dedicated resources where they're far more familiar with what's going on. We're working on implementing a whole bunch of Nagios style checkings, so basically host statuses, server statuses, and so on, where we can actually probe that ourselves. But that's not actually, I haven't thought of a good way to implement anything that really represents the kind of user-facing experience, kind of overall exercise, or in Greg's language, exorcism of the basic infrastructure, see what's going on. So that's where our grid exerciser comes in. All this is really it's a periodic submission of a DAG workflow that tests a bunch of important user-facing functionality. So things like, are we actually getting to various sites? Can we find and access data at various sites? And some other bells and whistles that I've added recently. All of those job histories are then aggregated into Elasticsearch by the, I think, fairly new Condor AdStash tool, which has really been helping me a lot debug problems and user-facing issues. So advert for AdStash. And then those all, aggregated and rendered onto various Grafana dashboard panels and, in principle, a daily email summary that's currently broken. The other thing, as I mentioned, that I am interested in testing on a regular basis is new functionality. So for the past couple of months, I've put a bunch of work into overhauling that DAGman workflow to basically, transition entirely to site tokens, test out all the different types of DAG nodes that I possibly can, and do things like write DAG files on the fly. And one of the nice things about that is I can then use that as a basis for internal documentation and pointing users at, quasi real life examples of how to do things. Okay, so yeah, where was I? I was basically giving the overview of, that it's this periodically submitted DAGman workflow with that tries to test all the things our users are typically interested in, and then all of the features that I'm interested in, that we've requested from Condor and OSG more broadly. So I probably don't need to spend too long on how the periodic submission happens, and it's partially just historic, but I chose at some point to do this by abusing our internal GitLab CI deployment pipelines. So basically, there's these scheduled jobs that run every CI pipeline jobs that run every 3 hours that have a bunch of functionality to go and check the things like the success or presence of the previous instance of the DAGman workflow. I don't want to be continually submitting the same thing if the previous instance is running. various authentication and copying workflow files over to the access point. And this basically all happens just via simple SSH, including the submission. And I have a handful of delayed jobs that are designed to go and check the status of that workflow and start yelling at me by email if things look like they're going badly. Given the chance to do this from scratch all over again, I would probably consider just doing this all via Condor. But this one thing I like about this is it kind of mimics the entire user experience, including actually logging in to the access point. So there are some benefits, and you get nice pictures. So I'll just run probably very, very quickly through some example panels from the dashboard. The dashboard itself is way too sprawling and huge to really flash up. But I have these kind of fairly strategic overview panels that basically just show tables of job success, number of jobs, success rate, in principle, good put. I'll come back to that. And remote wall clock times as a function of site. And things that I want to look for here are very low success rates, suspiciously short wall clock times, and again, in principle, low good put, although that's not that meaningful for reasons that I'll get to later. And I also find it interesting and useful to, keep an eye on the rough number of sites that we have running jobs in the open pool at any time, or which have run jobs, since it's all history. Okay, so some of the more useful information I can dig out of here are basically looking into where jobs are failing with high frequency. So just to point out that periodicity, and those are my grid exerciser jobs, as well as everyone else's jobs. It's just because a lot of things failing at that unknown site. And that unknown site is the local Caltech pool. But yeah, I can, it gives me an easy probe of the ranking of where jobs are failing horribly. And then I can drill much further down into that with various filters, including our counting tags. I can, arguably shouldn't, drill down into actual individuals, users, and I can obviously restrict it by the commands that have been run. So for example, if I see high rate of failure for say the Rift accounting tag there, the next thing I would do is start filtering down in practice on the user and the application that's actually failing, which I can do by just reprojecting that data in the different bar chart or pie chart if you prefer. And then, of course, I can filter on site as well. If there's one particular site that this person's Rift application jobs are failing at. And then, kind of to illustrate that a little bit more, that's essentially exactly what I do when I look at the grid exerciser output on this dashboard. I filter down to the accounting tag that I use, so I know that it's just my test jobs that I'm looking at, reproject the data and see which application is failing, which test essentially. And invariably, the thing that's always failing the most is these authenticated CVMFS access tests for various reasons. Yeah, so to basically wrap up a little bit, leave some time for questions. I did have a major problem recently, technically still have. So I mentioned that I'd overhauled this DAG workflow to include and demonstrate all these fancy new DAGman features, including the service node feature, which I think LIGO had requested explicitly as a monitoring tool. So that was actually completely broken. And for the past few weeks, DAGman in this workflow, which uses service nodes, started throwing assertion errors, and the DAG never left the queue. But thanks to Cole, that's well understood, and I'm sure will be patched by the end of the week. Yeah, I alluded to this as well. I think I'm right in saying that we don't have an easy, meaningful measurement of good put for self-checkpointing applications. So the typical measure that we use, as far as I understand it, is the committed time over the remote wall clock time, and the committed time gets reset after every checkpoint. So that would be really nice to fix, because as I think I alluded to it. One of the pipelines where I would really like to know what the good bit looks like is very much a self-checkpointing application. And then for the rest of these are basically related to authentication and file transfers. I think it was discussed a little bit yesterday. One of my tests recently has been to look at how well the OSDF client and Stash performs relative to CFMFS. But of course, when those jobs fail, they actually just get placed on hold. So I actually want to see failures. That's, I think, pretty easy to fix in my tests. I think it's possibly an open question as to whether that's desirable behavior. And then finally, and I think leads quite well into Jim's talk, is I've had, as I said, I've kind of overhauled this in the past month or two to transition entirely to Psi tokens and payloads. I've had quite a few teething problems with that transition. So generally, Psi tokens and Condor submit works beautifully. It's really intuitive. I've had basically no problems. Condor submit DAG, however, has been a little bit more hairy to understand exactly what's going on and understand, the various conditions where you should expect Psi tokens to work and the various things that you have to do or not do before you submit the DAG. I think that these are all ticketed in Jira. We could probably discuss further offline, but yeah, those are my current gripes and general impression. Thank you.